As we said, we're going to talk about analysis, mysteries, and dramas. Let's rewind a little bit and look into our mind and the way we think, as we said earlier, thinks, concepts. Secondly, their relationships. Thirdly, within the same diagram, their abstraction. This is our mind map. We create a diagram that presents that. We call this business concept modeling. This is the fifth artifact we talked about earlier in our presentation. So we're just going to focus on that. And I want to tell you about what we call some mystery and drama. Here's a diesel engines manufacturer that asked us to come and give them training. They had some real concern. We had those 6 engineers come to the training and tell us about their problem domain. So first we went through training, and then they said, okay, let's apply that to our own problem domain. This is something we do very frequently. We call that a corporate case study. But there were a couple of very peculiar things. First of all, those 6 engineers were highly competent. They had been working anywhere between 16 and 35 years for the same company. They knew everything about their own specialty. And in order to make any decision whatsoever, they had to come together, the 6 of them. And then they could make very important engineering decisions, except that for a little while they had realized they had harder and harder times making decisions. So you put those 6 great engineers together, and what comes out of it is difficulties. Difficulties. They would never agree anymore. That was a mystery to me, because that's a diesel engines manufacturer that has been around for so many years, and they're very successful. So what is the situation? I propose, well, let's think for a minute. After all, you're a diesel engines manufacturer, right? So we can start with one concept, one very simple. May I suggest that engines? May I suggest that you build engines, and there are some characteristics like horsepower, serial number, VIN, and also this very well-known engineering feature of a diesel engine, which is called the starter center distance, right? All of you are familiar with that. And I thought I had made the first step, which they erased immediately, telling me that this was the path towards perdition. It was not going to work. It was too concrete, which really gave me a wake-up call. Well, what's going on? They have an abstraction issue. Let's try to see. We sat down, talked about it, and whatever anyone would propose, 2 or 3 other engineers, at least one in fact, one engineer, not always the same, would say, no, this is not going to work, and we were stuck. I thought it was going to work. My plane was going to take off in about 3 hours. So in front of that, I thought, well, let's really go back right to the very beginning, and I said, let's start with something that all of us agree upon. And I could hear that silence, and everyone thinking, well, what are you going to try, man? It's not going to be agreeable upon. Let's try this. How about that? This is one thing. There's only one. Do you all agree with this? Of course, was I kidding, more or less? And they looked at me very seriously, and some of them were nodding. They agree on that. They agree on that one box. I say, okay, good. Now, could we, if I may ask, name it? What is it that all of you agree upon, which you do in this company? They said, things. So here I am with that box, right in the middle, everybody agrees upon thing. Could we call it engine? Could we call it what have you? No, it has to be a thing. Otherwise, it's not going to work. And again, my plane was going to leave in about 2.5 hours. So you remember this business vocabulary artifact I told you about? It came to my mind, and I thought, okay, tell me more about those things. What are they? I will say they are things. Okay? What are they made of? What are those things made of? They had to tell me. It's made of pistons. It's made of whatever you find in an engine. And they said, no, it's not made of that. It may, but it is not necessarily. Then what it is made of? They say it is made of things. So here we are. We all agree upon that what we're doing in that company is things that are made of things. Have we made any progress? So somehow, the one progress I could see is that everybody was agreeing that we had something we could start from. They liked the abstraction, but they still couldn't name it. Nobody would dare naming it, lest someone else would question that. So, they say that necessity is the mother of invention. So another question came to my mind, which was, well, what are those things that you can do with and that cannot be done with other things? And then one more word in the vocabulary came up, which was deliverable. We can deliver this, and we cannot deliver others. Deliver things, deliver other things that we cannot deliver, but we can call them parts. Now we were starting to talk. Very quickly we came to something of, as you can see, deliverables. A component is the abstraction. It could be a part or it could be a deliverable, and deliverable is made of other components. This again is the class diagram syntax that we'll study together very, very soon, and that really is not complicated. The challenge there was putting everyone's minds together and starting to agree while being abstract, starting to agree on some terms. So this is working in the abstraction. We certainly have here the abstraction of component, but we also have the relationship between, for instance, deliverable and component. A deliverable is made of components. And as we talked more precisely, this abstract part would be the element. The one that would not contain anything would be a part, and the one that would contain other things would be called a subsystem. So from that point on, we could start building, and to my great surprise, after about half an hour, the entire model was written. And I can show you this model as a preview. Here it is. And we'll study this later, where you can see your elements, your part, your subsystems. So again, they changed the wording a little bit. And this diagram, though it's one of the more difficult problem domains that we'll study by the end of the class, definitely is the solution. They have right here in the center what an engine model is made of, because when you build an engine, it is based upon a model, right? So now the model is made of those elements that are made of other elements. All that is governed by rules that predict the features you will get from the engine, like, for instance, the horsepower. And if you go down this part of the diagram, you will have the different attributes of your engine and how it matches, how those attributes and their values are going to match the requirements. The engine is delivered to the client. The client has requirements. So you have, in this very simple single model, the solution that company had been looking for about 15, 20 years. So this is something I want to mention to you. There is no reason whatsoever why you would not be able, after we have been through this entire analysis course material, to do it yourself. No matter how complicated it is, in this case, we've been able to solve the problem using abstraction, as well as the other features, of course, but abstraction was the key. It was very interesting to see that a team of engineers always ready to battle against each other. Now you could see with their body language, they were leaning backward, they were sitting, they were relaxing, they were smiling, talking to each other. For the very first time, they were able to draw one picture that would put everybody together, or everybody's thinking together into one unified way. What models for their engines, what they are made of, the rules to predict what an engine will be providing, what type of attributes an engine will be offering, or what an existing model is offering, everything, the requirements, the client. After that, once they had this model, they just went out to the market and bought the software that was the closest to this. And they found one that was very close. We're talking of a project, total project of what? 3 months against 25 years. Let's think about that. Again, all we need is to use a proper language, which is definitely the case of unified modeling language, but in such a case that as opposed to being a diagram only some technical people will understand, it has to be a model that properly reflects the business concepts, their relationships, their abstractions, everything together. This is the method we're about to go through and that you will be able to master by the end of this week.